Okay, I'm going to take questions off of the exam review today. If you have specific questions about the exam or about the exam review, please let me know.
Hi, Professor.
Hi, Erica.
Can you do number 8?
Sure. So I have 8 and 12 on the board now, I guess. Okay. So we'll do those in order. Sorry, 1 second. All right, my bad. Okay, so we'll do 8 and 12 to start off with. Okay, number 8 says, find the second derivative for z equals y tangent 7x, right? Okay. So, let me share my screen here real quick. Okay, so once again, that was z equals y tan 7x. Okay, z equals y tan 7x. Z equals y tan 7x. Okay, and we want to know what's the second derivative with respect to the second partial with respect to x, right? Okay, the second partial on z with respect to x. Okay, well, yeah, just take this with respect to x twice, right? Partial of partial, okay? So, okay, so let's do f sub x. Okay, what's f sub x of this? Well, this is going to be 7y, 7y times the derivative of tangent. Okay, derivative of tangent is secant squared of 7x, right? So that's that guy, okay. Okay, so now let's do f sub x of x. Okay, so 7y. Okay, the derivative of secant is secant tangent. So we're gonna, because again, that's chain rule. How I got the 7y was the chain rule. Okay, and so this is gonna be 49, because I'm gonna do the chain rule again. okay, 49y times, this is going to be secant 2 secant x times secant x tangent x, right? Okay, so that's 98y secant squared x tangent x. Is that right? Let's see. Let's see if that's right. That's right. Okay, that's number 8.
Okay, I get it now. Thank you.
Yeah, sure. Okay, number 12. I'm going to do number 12 now. Okay, the linearization of the function at -1, 1 to approximate this bad boy here. So, okay. Yeah. To approximate this thing here. Okay. So -0.93 and 0.75. Okay. So let's just do the linearization here. Okay. So this was number 8, by the way. Okay. So let's go to number 12. Okay. So we have f of xy is equal to the square root of 9 minus x squared minus 2y squared. Okay, and we want to know what's the linearization at -1, 1. Okay, so what's the linearization formula? Well, it's this guy here. L of xy is equal to f of ab plus f sub x of evaluated to ab times x minus a plus f sub y. Oops, what the hell happened there? Okay, sorry. F sub y evaluated at AB of y minus b. So let's find our f sub x and f sub y. So our partial with respect to x here is going to be, okay, 1 over 2 radical 9 minus x squared minus 2y squared times derivative of the inside, which is -2x. 2's cancel. I'm left with -x over the square root of 9 minus x squared minus 2y squared. Okay. And so, yeah, that's good. Okay, what about f sub y? What's f sub y going to be? Very similar, except we're going to end up with a -4 on top and a 2 on the bottom. So this is going to be -2 y over the square root of 9 minus x squared minus 2y squared. That's f sub y. Okay, so again, what's L of xy? Okay, what's the linearization of this function? Remember, at this point, -1, 1, right? What's the equation of the tangent plane that is tangent to this point? And so I'm going to use that tangent plane as a value, as an approximation for close values, right? We're going to use this tangent plane as an approximation of the original function at close values. We're saying that values that are close to -1, 1, they're not going to deviate too much from this tangent plane. So we're just going to use that as an approximation. Okay, so this says f of AB. Well, what the heck is f of AB? Well, let's just plug it in. F of -1, 1, right? F of -1, 1. Okay, plus f of x, f sub x of negative 1, 1, times x minus negative 1 plus f sub y of negative 1, 1 times y minus 1. Okay. So let's find out, well, what's f of negative 1, 1? Well, what's the original function? The original function was 9 minus x squared minus 2y squared. Okay, so yeah. So this is going to be 9 minus 1 minus 2. I'm going to say that's radical 6. That's the square root of 6. Okay, plus, okay, well, we already know that the denominator here is radical 6. Okay, for f sub f of x, right, because the denominator is the same as the original function. So this is going to be negative x. Well, what's negative x? Well, that's going to be 1, right? So wouldn't this just be 1 over radical 6 times x plus 1? Okay, plus, okay, well, what's this one going to be? Well, that's just going to be 2 over radical 6 times y minus 1. Oh, okay. And that's L of xy. And now it's saying use this guy as an approximation to the original function value, okay, at the point negative 0.93, 0.75. So L of negative 0.93 and 0.75. Okay. And so we're just going to plug this in. Okay. I'm just going to say, oh, okay. So this is going to be radical 6 plus 1 over radical 6 times negative 0.93 plus 1 plus 2 over radical 6 times 0.75 minus 1. If I plug that all into a calculator, I should get approximately 2.68. Okay, so that's number 12. Okay. Okay, so I had another question about level curves and the gradient. I mean, the gradient is just the partials, right? The gradient of f of x, y, z is just the partials. Okay, level curves are when f of x, y, z equals k. That's a level curve. Okay, I would highly encourage you to go back and watch my YouTube videos. Okay, you know, go back and work through some of the homeworks and watch the YouTube videos. There's even videos in the homeworks as well, but you have full access to all of my lectures, right? So if you go to the syllabus, I don't even know did I link, is there a link in here? If you go to the syllabus, right, and you go to my actual syllabus page, well, I don't want to download it, just look at it. It should have a link to my YouTube channel. Okay, so where's the YouTubes? Here, right here. Okay, and so if I click on that link, maybe I can't do it in here. Maybe I have to actually download it, but will it let me do anything? I don't think so. Hello? Oh, it will. It will. Nope, it won't. Oh, it will. Okay, so go to. It just says, I right click on it and then I hit go to. Okay, and it says, look, here's your professor's YouTube channel. Right? And you're like, I want to know more about level curves. Okay, well, what part of the chapter was level curves? Maybe 14.2 or 14.3? Let me see. I don't have that memorized. Okay, what was it? Oh, it was 14.1. Okay, so 14.1. Okay, so you just say over here, you're like, oh, okay, well, what's his videos? Oh, there's a playlist too. Of Math 280. You're like, oh, view full playlist. And you're like, oh, okay, so go here and 14.1, 14.2. So you just watch the first hour of this. And there you go. You get to have the re-lecture. You get to be re-lectured to by me as many times as you want.
Okay, thank you.
Sounds good. Okay. Anything else that you want to cover?
Could we go over number, I think it's number 5. It's finding or using the polar coordinates to find the limit.
Yeah, sounds good. Let's do that. Number 5. Yeah, okay. Okay, number 5. Okay, we want the limit as x, y approaches 0, 0. Okay, of x cubed plus y cubed over x squared plus y squared. Okay. Yeah. And they're saying we're going to use some polar coordinates to help us do this. Okay. So could we do it without polar coordinates? I'm wondering. I don't know. Let's do the polar coordinates first, and then we'll see. We'll see if we could even do this without polar coordinates. Okay. So let's prove. Well, basically, it's a proof, right? We're proving what the limit of this thing is, and I think the only way to prove it is to use polar coordinates. Honestly. Okay. So let's change to polar. And we're going to say that x is equal to r cosine theta and y equals r sine theta. Okay. Okay, so this is going to be now x r cosine theta cubed plus r sine theta cubed over r cosine theta squared plus r sine theta squared. Okay, so this is going to be equal to r cubed cosine cubed theta plus r cubed sine cubed theta all over r squared cosine squared theta plus r squared sine squared theta. Okay, so now let's just factor out the r's, an r squared on the top and an r squared on the bottom. R squared times r cosine cubed theta plus r sine cubed theta all over r squared times cosine squared theta plus sine squared theta. That goes away. This becomes 1. So we're just left with r cosine cubed theta plus r sine cubed theta. Okay. And now we don't have the worry of dividing by 0. There's no division by 0 now. So let's see what let's take the limit as xy goes to 0, 0. However, what is r theta at 0, 0? Well, r is equal to the square root of x squared plus y squared. So that's just going to be 0 plus 0, that's 0. R is 0. And then what's theta? Theta is equal to the inverse tangent of y over x. Well, that's a problem. Okay. Because we would end up dividing by 0. Okay. So, but that's okay because we don't really care what theta is, right? In this case, let's just kind of ignore it. Because when we plug in 0 for any theta, right, what happens to the whole thing? I mean, if r is 0, this becomes, let's say that this becomes the limit, okay, of r theta goes to 0 theta, right? 0 theta, for any theta, right? Because think about polar coordinates, right? If r is 0, aren't you on the origin anyway? Does it really matter what theta is? It really doesn't matter what theta is. I mean, theta could be 360 degrees, and it really doesn't matter. If your r is 0, you're stuck at the origin. You can spin around forever and ever if you want, but it's really not going to mean anything. Okay. So when I plug in 0 for r, then this becomes cosine cubed theta plus 0 times sine cubed theta, which is 0. Okay. So the limit is 0 for that guy.
That makes sense. Thank you.
Sure, absolutely.
Professor, I was having troubles with number 16.
Okay. Good. Okay, number 16. Okay. Oh, nice. Yes. Yes. Laplace a Lagrange multiplier. I can't keep those French guys' names in there. The Laplace transform is from differential equations. That's the next class that you're going to take. Okay. A Lagrange multiplier is solving these systems of equations. Okay. So yeah, let's go over this. Okay, so we look at 16 here. Real quick. Where did it go? Where did my 16 go? Let me pull it up again. Oh, I know I got rid of it. It was on the wrong computer. Okay. Stop it. There we go. Okay. Okay. Use Lagrange multipliers to find the minimum value of the function subject to the given constraints. Okay. So, yeah. This is a nice one. Okay. So we have f of x, y, z, and t is equal to 7x plus 7y plus, can everybody see my screen okay? Okay, good. What the heck? Why is this there? Oh, I know why that's there. Got it. Okay, plus 7z plus 7t. Okay, so that's my f of x. Okay, what's my f of y? What's my my constraint? My constraint is that 7x squared plus y squared plus z squared plus t squared is equal to 8. That's my constraint. So my function, that's what I want to minimize or maximize. Okay, and then this is the constraint that I'm constrained to. Okay, so yeah. So we want the gradient of f is equal to lambda times the gradient of g. We got to know, well, what's g in this case? Well, g of x, y, t, g of x, y, z, t is equal to 8. Remember, the constraint is that we have some sort of function equal to a constant. Okay, that restricts. Okay, it's called degrees of freedom in statistics, but you know, this restricts 1 degree of freedom. Okay, by putting an 8 there. Okay, it tells me that, hey, this function is constrained, okay, by 8. So this thing is my g. Okay, so what's the gradient of this function? Well, what's the gradient of f? Well, that's just going to be f sub x, f sub y, f sub z, f sub t. And this is going to be lambda times g of x, g of y, g of z, and g of t. Okay. And so what's f sub x? Well, that's just going to be 7, right? So these are all 7s. Okay. What's g of x? Well, that's going to be 7 times 2x. Well, that's just 14x. Right? Okay. Okay, so let's I don't know. Let's set these equal to each other. This is going to be 7 times, or 7 is equal to, distribute the lambda. Okay, lambda 14x. 7 equals lambda 14y. 7 equals lambda 14z. And 7 is equal to lambda 14 t. What does that tell me? Well, that tells me that x is equal to y is equal to z is equal to t. Isn't that what that tells me? Right? That makes sense. Okay. So now we could actually solve for these values. How? How do we solve for these values? Well, we have, you know, an equation that we can solve for. We now can plug this into the 7x squared plus y squared plus z squared plus t squared is equal to 8 and solve directly for x, because this is going to be 4x squared times 7 is equal to 8, right? Okay. Divide by 28. Right? And we're going to get x squared equals 2 over 7. So x equals plus or minus radical 2 over 7. Okay. And so, okay, so, and then, you know, similarly, y would equal plus or minus radical 2 over 7. Z would equal plus or minus radical 2 over 7. And t would equal plus or minus radical 2 over 7. Okay, so now what are we wanting to do? Well, we're wanting to minimize this function, f of x, y, z, t. I want to minimize this function. Well, what function? Well, the function 7x plus 7y plus 7z plus 7t. Well, which values are going to make this a minimum? Which values will make this a minimum?
The negative?
Yeah, very good. Thank you. Yeah, the negatives will make this a minimum. So I'm going to say, okay, this is going to be 7 times negative radical 2 over 7 plus 7 times negative radical 2 over 7 plus 7 times negative 2 over negative radical 2 over 7 plus 7 times negative radical 2 over 7. Okay. So now let's clean this up a little bit. Okay. So I know that this is going to be, well, it's just going to be 4 times negative 2 over radical 7, right? Times 7. So this is 4 times 7. We'll just do 28. Okay, times that. We could rationalize the denominator. This would become negative 2 radical 7 over 14. Sorry, is that right? No, over 7. My bad. Okay, over 7. And then this is 28, right? 4 times 7, right? Four times 7 is 28. 28 divided by, what did I do wrong there? Nothing?
Professor, it's radical 2.
Oh, thank you. Yes. Thank you, thank you, thank you. Okay, so radical 14. There we go. Okay, and so then this becomes negative 4 radical 14. There we go.
Okay, I see where I went wrong. Thank you.
Sure. What would the maximum be? Should be really easy to tell, right?
It'll be the positive.
Yeah. Exactly. I don't want to waste anybody's time. So if you don't have any more questions, you're free to go. Okay.
Professor, how many questions is the exam itself going to be?
I think it's around 10.
Okay, thank you.
Professor, can you quickly run through number 3, please?
Okay, so it's finding the domain. Is that what you're saying? Is that what this is? So,
yeah.
Okay, so 6x squared minus 2y squared minus, oh, what the heck is going on there? So number 3, 6x squared minus 2y squared minus z. Okay, that's in the denominator, so it cannot equal 0. Okay, so we can't have that equal 0. So what I'm going to do is I'm going to solve for z here and put my answer in terms of f a function of z, a function of x and y. Okay, so I'm just going to toss everything to the other side. Z is equal to negative 6x. This is minus, sorry, positive 6x. Let's just toss z to the other side. So this is 6x squared minus 2y squared. Okay, cannot equal that. So we just say that, hey, you know what? X, y, we want all values of x and y such that, that's what this means, this line means such that. Okay, all values of x and y such that, okay, such that what? Such that z is equal to, or you could say f of x, y is equal to, or sorry, is not equal to 6x squared minus 2y squared. Such that, okay, that's true. That's the domain. Okay.
Professor, I have a quick question.
Yes.
In the exam, most of the grade will be on the final answer or also on the steps?
Both. It's always both.
Oh, okay. Thank you.
Okay, let's just call it a day there, and I'll see you guys on Wednesday. Okay?
Thank you, Professor.
Yeah.
Thank you.
Thank you.
Thank you.
And if you have any questions between now and Wednesday, you can always email me.